Hey there, everybody. Welcome back. This is Mr. Sheeline. We're going to be going over Unit 1.1 notes covering one-dimensional motion. If you are here to just see the answers at the end, just skip forward. Whatever the timestamp is, I'll put it in on the video. You can see it here. Go to that timestamp at the end of the video to see the solutions for the Check Your Understandings. So let's get right into it. All right, linear motion. So you need to be asking yourself, and you need to take time here for a hot second. What is motion? How do we describe it? So I want you to do is I want you to write down in your notes. You've got a little box right here. Write down what you think motion is and how we describe it. Okay. So pause the video, write your answer, and then get back going. All right. So you should have paused it. So this is what you should have come up with, or at least what I would accept motion is and how we describe it. So motion is a change in position or placement, okay? Or it could be used as a change of time, okay? Now, how do we describe it? Well, we describe it as in, position is here, position is there. You go from here to there. Change in time, it could, it's very possible that that's how you describe it. As you know, us Americans, if you ask, well, how far is this thing? We don't ask that question thinking that the answer is going to be in an actual distance. It's going to be in time. Okay. Well, it takes me about an hour to get to Rockford. Oh, well, it takes me about 2 hours to, how far away is Chicago? Well, it takes me 2 hours to get there. So those are two ways we can describe it. So then what is the difference between something changing position and then something that travels a certain distance? So be thinking about that. We're going to be kind of getting into that, okay? This is more or less the overarching idea of linear motion, one-dimensional motion. Okay. So understand, you've probably have seen and heard the word kinematics. So the kinematics, simply put, is the study of motion. It's the measurement, calculation, and recording of motion. Okay, that's kinematics. And you should hear something like that because in the word kinematics you should see kinetic. Okay, what is kinetics? Well, kinetic can be it is the measurement function of something in motion. Okay, like kinetic energy, it's energy put into moving something. Okay, or it's the energy from a moving thing. So we also have to understand that there are, different kinds of motion. We've got uniform and non-uniform motion. So uniform motion is movement at a constant speed in a straight line. Okay, it's unimpeded. We differentiate these two, or at least scientists differentiate these two when talking about different examples, different ways of studying a particular thing. Because uniform motion, typically used in the classroom is much easier to apply and it's much easier to think of and to work with than non-uniform. When you have to mix in all the muddiness of life, this thing or this car drove in this direction and then slammed on their brakes and then they turned left and then they got into an accident and then that person was running. There's so many different points in there that motion changes. And that's non-uniform motion. It's where motion changes in speed or direction or both, and that's life, and it can be tricky to calculate, and it's something a little bit more advanced, something a bit more advanced, but you will learn a little bit as we go along. All right, so take this time now, pause the video, and answer these questions. You can find the answers here in the slide presenter's notes if you exit the presentation. So challenge yourself, answer these first, and then come back, okay? So pause the video, and we'll come right back. Okay, so check your understanding. So again, you can check those answers in the notes, but those are the answers you should have came up with. If you didn't come up with the same answers, make sure that you ask me, Mr. Sheeline, why is it that, the rubber stopper, blah, 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 blah. Okay, why is it that the rocket, blah, 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 blah. Make sure you ask me if you don't understand. All right, scalar versus vector quantities. So a scalar quantity is a measurement that has magnitude or size, okay? And it only has that. It doesn't have direction, okay? So an example of that would be kilometers per hour, miles per hour, meters per second, kilograms, and we measure, and what is a scalar quantity is speed, okay? And opposing that is a vector quantity. It's a measurement that has both magnitude and direction, okay? And examples of that would be something traveling at a rate of kilometers per hour west, something accelerating meters per second squared and I've got a comma there that shouldn't be there, but it should be meters per second squared west of north 23 degrees. And velocity is an example of a vector quantity, okay? All right, so here's another check your understanding. So pause the video again, answer these the best you can, and then check your answers on the notes. Pause your video. All right, and we're back. So you can check the notes, the speaker notes for the answers here. Again, if you do not understand why something was a particular answer, let me know. We can go through it, we can discuss it, and I can show you why it was, or why the correct answer is correct. Okay, moving on. So the definition of speed, now that we know it's a scalar quantity, is just a change in distance over time, okay? It's a scalar quantity. And velocity is a speed in a very specific direction, okay? And it is a vector quantity, okay? Now, both of these, though, use different measurements. They use different variables in order to calculate them, okay? Now, before we get into that, though, and that was just to tell you, so you understand, but before we get into that, just understand, we do talk about average versus what's called instantaneous variables. In this case, average versus instantaneous speed. There is also instantaneous and average velocities, instant and average, or instantaneous versus average acceleration, et cetera, et cetera. It is just a way that we break down specific intervals of measurement. So instantaneous speed is speed at a particular instant, okay? And the symbol we use when we're talking about instantaneous speed is just a simple V. And then we have average speed, which is the total distance traveled divided by the total time of travel, okay? And the symbol we use for that is V and then subscript AV, okay? AV just standing in for average, okay? And the equation that we use, and this is going to be a common equation we use for all of motion for the most part, as you'll see. So the average speed equation is going to be V sub AV is equal to D over T, where D is distance and T is time, okay? Okay, so let's take this equation and now let's apply this and check your understanding on it, okay? So answer these questions. Pause the video and then answer these questions. The answers are found in the speaker notes, so go there. At the end of the video, I'm going to walk through how it is that we find these answers in case that there's something you missed. Okay, so pause the video, answer these questions to the best of your ability. Okay, so we're back. If there was something you didn't understand, let me know, and we're moving on. Okay. So velocity and other vectors. So just like speed, and as I said before, velocity can also be measured and expressed as instantaneous or average. And when expressing, and when we write down the answers for this, we have to express the direction traveled. And to do that, we either put them in the full form, which would be like we're going 5 meters per second west. Okay, we write out west, or and we put it in brackets, or we put the abbreviation in brackets. And we have to make sure we do this for every vector quantity. Okay, so here are 2 examples of doing so. I should have square brackets around the west as well. I don't know why I left those out, but there should be square brackets around that as well. Okay, so I mentioned earlier that speed and velocity use different variables. So speed uses direction and time. Okay, but because velocity is a change in time over in a specific direction, it's a vector quantity. We don't use distance. Okay, we use something else. But before we understand what that is, we've got to understand what position is. So position is a directed distance of an object from a reference point. So, if you're position A or if you're position B, what's the relationship between this position to a different position? Okay. Now, we understand that, and we use position or distance for speed, but displacement is used for velocity. Okay, displacement is how far an object is from its starting point. Okay, doesn't matter, how many other reference points, how many other positions there are from, one to another. So, if you start at position A, and you are at position Z, it doesn't matter all the other positions between the two. All we care about is how far are you in relationship to position A if you're at position Z. Okay. And the symbol that we use for that is delta D with an arrow over top of it. Okay. The arrow tells us it's a vector quantity, and then that triangle, that delta, tells us that there's been a change. Okay. So it's delta D with an arrow over top of it. Okay. And to find our displacement, what we have to do is we subtract the starting position from the final position. Okay. Easy enough. So whatever your final position is in relationship to your starting position, we subtract the starting from the final. Okay. So let's try this out. We're going to try out distance and displacement. We're going to see if we get it. So do this, check your understanding. Again, the answer to this is going to be at the end of the video. Pause here and answer the question. Okay, so we're back. If there is anything you don't understand, let me know, and I can go through it with you. All right, so recall average speed is the total distance, blah, blah, blah. Average velocity is the change of position. It's your displacement divided by the time interval for that change. Okay. And the formula looks like this. So we've got VAV with an arrow over top of it now. Okay, because again, it's a vector quantity. It's velocity equals delta D with an arrow over top, which is displacement, divided by delta T, which is the change in time. Okay. That's going to be important, the change in time. So let's see if we can understand this. So again, answers are going to be at the end. You can skip to that, but let's answer this. Pause here and answer it, and then we'll be right back. Okay, so we're back. We have another check your understanding. Do the same thing here. Pause. Answer it, check the answer on the speaker notes, or watch the end of the video to see how it is that I got these answers. Okay, so I think we've got one more. Yeah. So answer all of these questions, check your answers. If there's anything you don't understand, ask me. See the answers at the end of the video. Okay. All right, so the last thing, this is the assignment that you have to complete. The idea here is to make a concept map of using all of these different terms. I want you to make a concept map to show me that you understand how these are all related, which one uses which, okay? And this is a pretty good example of a concept map. So we start with sports. Well, there are sports with a ball. There's a sport without a ball. Well, a sport with no ball would be track. That's obviously track minus field. So, track, we don't use any balls, but the sports where we do use them, we got football, volleyball, soccer. Okay. So I want you to recreate something similar to this, only using the terms that I listed in the slide before. Okay, so that is the lesson. I'm going to go through now. I got to kind of fix myself back to the slides to do this. But this is the point in which I'm going to go through those answers. So here, I'm going to exit out. Come on. All right. And we're going to go back. We're going to answer these questions. Okay. All right. So here. Sorry, this is going to take a bit. I don't know why my. Okay. All right. So let's take a look here as to how I solve this. Okay. So the question is, let me grab it. So the question for this one is here, average versus instantaneous speed. Okay. The track star running 4 laps of a circular track that has a radius of 15.9 meters in 47.8 seconds. So what's the runner's average speed for this motion? And then I've got a hint for you to remind you how to calculate circumference. Okay, because we're not given total distance. So let's write down what we know. So we know that radius here is equal to 15.9 meters. And we know that our time is 47.8 seconds. And what we're trying to solve for here is we're trying to solve for our average speed. So easy enough. The first thing we should do is we should just write down the equation, which is VAV over equals D over T. Now, we don't have distance either, so we're going to keep this over here, and we're going to solve for our distance using radius. So let's use that hint. So circumference is equal to 2 pi times our radius. So C is equal to 2 pi times our 15.9, okay? And we should get, for this, we should get 99.9 meters, okay? Now, we aren't done yet though, because we need distance. And it says here that they ran 4 laps. So in order to get distance, to get our full distance, we've got to multiply this by 4. And to properly get our distance, it's 99.9 times 4, and we should get 399.6 meters. Okay. Okay, so we've got that. We've got distance now. All right. Now, let's solve for this guy. Now that we've got distance and we've got time, we can solve for it. So we're going to plug in our materials here. 399.6 meters over our time, which is 47.8 seconds. Plug that into our calculator, and what we should get is 8.36 meters per second. And there's our answer. Okay? So again, it's important to read all of the necessary context clues in order to solve these questions properly. So that's how we get 8.36 meters per second for this question. All right, now there is a second question here. So the record time for the particular race is 3 hours, 53 minutes, and 17 seconds. Determine the average speed of this 42.2 kilometer race. And we've got to express the answers both in kilometers per hour and meters per second. So let's write down what we know. So we know that the time it took to do this was 3 hours, 53 minutes, 17 seconds. Okay. All right, we know that. And we know the distance was 42.2 kilometers. All right. We could also write that as 42,200 meters. All right. So first thing we got to do, though, is we've got to figure out what we want to, we need to break this up. We need to put this in this time in hours, or we need to put this in, and we need to put in seconds. Okay. So easy enough. If we want to put in seconds, we're going to multiply 3 by 300 or 3,600. Okay, because that's our multiple. That's 60 times 60. So to go from hours to seconds, we need to multiply it by this. Okay. Plus, we need to do the same thing for 53, only this time it's going to be 53 just times 60. And then plus 17, which is going to give us, let's see, where is it? Which we should get 13,997 seconds. Okay. So we got t in seconds over here. 13,997 seconds. And then to put it in hours, so t hours, here we can just keep this 3 plus, now it's going to be 53 divided by 60 plus 17 divided by, oops, not 60, but 3,600. Because we're trying to find it in hours, our time in hours. So that's then going to make our hours 3.8, we'll say 3.85 hours. Okay, so 3.885 hours. Okay, so we've got time. Now we've got distance, but we have to make sure that we keep these in the correct, what would be the word? We need to make sure we keep these in the correct order, because we want meters to go with seconds and we want hours to go with kilometers. So easy enough, we're going to write out our equation. So, and we are solving for average speed still, okay, which is VAV equals D over T. Okay, now let's solve. Okay, so let's plug this in. We're going to plug this in for both here. So, but we're going to start with kilometers. So we've got 42.2 kilometers. It's our distance over time in hours, which is 3.885 hours, which should give us 10.9 kilometers per hour. Okay, boom. And then to do seconds, we set it up the same way, but now we've got to use the proper units. So now it's going to be 42,200, oops, not kilometers, but meters over our seconds. So 13,997 seconds. We plug that into our calculator, and then we should get 3.01 meters per second. And then we've got our answers for both of these questions. All right, so that's the first math-based check your understanding. Okay, now let's now kind of move on. I'm going to move on here. I think I skipped that. Nope, I did not. Slide 12. Okay, so if you run around an oval track for 10 minutes with a perimeter of 350 meters and end where you began, what is our speed and what is our velocity? Okay, so let's start with speed. So speed, easy enough. We've got d, our distance, is 350 meters. And then we've got time, t, 10 minutes. Now, because velocity and speed, the units are meters per second, we need to change these minutes to seconds. So we're going to change that to whatever seconds is. So to go from minutes to seconds, we have to multiply by 60. So I'm not going to show you the math on that. It'll just be 600 seconds. But we don't know. We're trying to solve for our speed here. And remember, speed is VAV equals D over T. Okay. All right, well, we've got our units here, so let's just solve. So VAV is equal to, let's do 350 meters over 600 seconds. Easy enough. So our average speed should be 0.58 meters per second. Okay, easy peasy. Now let's ask the same thing about velocity. Okay, or sorry. Let's see. Yes, no, I'm looking at this right one, yeah. Okay, so that is our speed, but let's take a look here at our velocity. What would our velocity be? Well, let's think about this question. So we know that we've got time in there, and it took us 10 minutes, which, again, is 600 seconds. We know that. What was our displacement? So we ended where we began. Well, because we ended where we began, what is the relationship in those two positions, our starting and ending position? Well, there isn't any difference. It is 0 meters, okay? And so because our displacement is 0 meters, unfortunately, trying to solve for our velocity here, we just can't do it, okay? We just can't do it because you can't divide by or divide to or into 0. Okay? So because of that, our answer should be 0 because our displacement is 0. So velocity is 0 meters per second. Oh, and also around track. Remember, it's a vector quantity, so we have to establish the direction that it was traveled, that they traveled, so around track. Okay. Next one. Okay, so the cyclist. Let's see what we know for the cyclist. Okay, so for the cyclist, this is also going to be a pretty busy one. So for the cyclist, we know that we've got a time here, and the time is 25.1 seconds. We also have a displacement, because remember, we're finding average velocity, and the displacement is 115 meters east. Okay, and we're trying to solve for our average velocity. We don't know what our average velocity is. But we know the equation, and it looks like we pretty much have everything we need in order to solve this. So let's go ahead and solve for this because it's pretty easy because we started here and then we went this direction for 115 meters. Okay, pretty easy. Okay, so let's just do it. So VAV arrows is equal to 115 meters over 25.1 seconds. So our average velocity traveling eastward is going to be 4.58 meters per second to the east. Okay. Pretty straightforward. We've got the first answer pretty much done. So this was the first answer. So let's see, it says here that if the cyclist maintains the same average velocity for 1 hour, what is the total displacement? Okay. Now, so if they continue to travel at this rate, okay, at this velocity, in this direction, what's their displacement after an hour? Okay, so we've got our time will be an hour, which is equal to 3,600 seconds. Okay, so trying to solve for displacement. Okay, so simple algebra here, guys. So we know that the equation that we've been given is our VAV is equal to displacement over time. Well, easy enough. If we've got to solve for this guy right here, we're just going to shoot him up there. So instead of it being VAV is equal to d over t, it's going to be displacement is equal to, and I'm going to take this up here, displacement is equal to our average velocity times delta t. Easy enough. So let's plug them in. So it's going to be 4.58 meters per second times 3,600 seconds. Okay. And then what we should get, we should get 16,488 meters to the east. If we were keeping sig figs, it would be 16,500 meters east, or 16.5. Yeah, there we go. 16.5 kilometers east. Okay. And that's our displacement if we keep going that direction for an hour. Okay. All right, so the third part of the question. So the third part of the question, let's say they turn around. Okay, so they started, we went this way for 115 meters. Okay, but let's say right here, we decide to turn around. We're going to go this way. And this isn't the scale, obviously, but we're going to go this way for 565 meters. And this is to the west, and this is to the east. All right, so we need to first find our displacement. So we started here at D1, then we went to D2, and then we ended at D3. Okay, but we need to establish what our displacement is. So we need to know what's the difference between, or what's the difference in distance between this spot and this spot. Okay, and the best way to do it, because we are using uniform motion and also just linear, this is linear motion, okay, just walking on a straight line, we know that it's pretty simple. We just subtract one from another. Okay, so we're going to subtract our initial from our final. So it'll look like this. Okay, we're going to take our 565 meters minus our 115 meters to get our final displacement, which our final displacement is going to be, where are my notes at? I've lost my place, sorry. And I could just do this in my head. 450 meters. Now, oops, sorry. But so because this is a vector quantity, we need to know the direction. So what direction is D3 from D1? Well, it's definitely not east of D1, so we've got to say that it is west. Okay, it's 450 meters west. So here's our displacement. We've got 450 meters west. Okay. And the thing is that we have now traveled with 2 time intervals. Okay, so we've got delta t from D1 to D2. So we can go 1 to 2. which is, let's see, 25.1 seconds. And then we've got delta t from 2 to 3, which is 72.5 seconds. Now, what do you think we're going to do with those? We're not going to subtract these, because part of the time for the average velocity, it has to be the entire time interval from beginning to end. Okay. So we're going to add these two together. So to find our final time, so to find t, we're going to sum up 25.1 seconds plus 72.5 seconds, which should give us a time of 97.6 seconds. Okay, so my screen's pretty much full. I'm going to erase it, so just keep in mind, though, I've got the time and I've got displacement here. Okay, so I'm going to take these two with me on the new, after I erase everything here. Okay, so we've got delta D. So we've got displacement. Displacement, remember, is 450 meters west. And then we've got our time. And our overall time, our total time, is 97.6 seconds. Okay. Now what we got to do, we've got to find the average velocity from our ending position to our, or from our beginning position. But the equation is going to be the same. Okay. Okay. So all we got to do now is plug everything in. So VAV is equal to our delta, or sorry, our displacement, 450 meters over 97.6 seconds. And if we plug that into our calculator, we should get 4.61 meters per second. There's something that you may have forgotten, because we got to pull this along with us. West, it's going to be 4.61 meters per second west. Okay, I know this is a whole lot, but we've got one more. Okay, so all these answers, I have the 1 through 4 on this one. I've got plenty of explanations. They should make sense. If they don't, ask me. We're just going to do number 5. Okay, this is just going to be number 5. So the truck driver reacting quickly to an emergency applies on the brakes. During the driver's 0.32 second reaction time, the truck maintains a constant velocity of 27 meters per second forward. So what's the displacement during that time? Okay. So easy enough. We've got time, 0.32 seconds. And we've got average velocity, or constant velocity. I guess it's average velocity that happens to be constant velocity. And what we're trying to figure out is our displacement. And we've, for the most part, I think we've already done one like this. Easy enough. Let's rewrite real quick our equation, which is VAV is equal to D over T. Okay. We're going to bring this guy up here, because remember, we're not solving for this. We're solving for this guy. So since we've already done it, I'm not going to walk you through it. It'll be D is equal to VAV times delta T. And we can just plug in our values. So our displacement is equal to 27 meters per second times 0.32 seconds. And what we should get for our displacement should be 8.64 meters forward. Okay, easy enough, guys. So these are the answers. If there's still something you don't understand, make sure that you talk to me. Make sure that you see me, so we can figure it out. We can see what you're not understanding. But that's the video. So again, if you have any questions, let me know. Email me, send me anything on your mind, whatever it is. So thank you guys.